All right, so in this video, I'm going to continue to introduce the commands in Pandas. So last time we how to create a data frame, and then how to the uh, to change the index and rename the column labels, and then how to find out duplicate examples and so on. So we have seen pretty much many the command. So now we're gonna study the grouping data. Okay, so see grouping data. So give me a second. So in grouping data, here's we're gonna learn the how to split a data frame, okay, and then how to apply a command for finding specific array once we split the data, and how to combine the split data. Okay, so or we just apply the split. We're gonna how to do split, apply, combine simultaneously. Okay, so give me a second. So you don't have to type this one, okay? So you can see this one in the, give me a second. So you can see this figure in the Python data science textbook, okay? When you go to the Blackboard, I post the link, Python data science textbook, click it, and then go to the grouping in chapter Python, pandas. Go to the chapter pandas and then search the grouping, the section. Then you can see this figure. So this one, I think this figure really nice. Give a really good understanding. Um, give you the understanding how the what's the grouping in pandas. So here's the input data frame right there, and then they split. You see that for they're gonna split by the the key value, right? So we just kind of grouping for each key value A, B, and C. Okay, and then apply. For example, we want to find out sum of all the data for the same having the same key value. So 1 plus 4 is 5, and 2 plus 5 is 7, 3 plus 6 is 9. After the apply, and then we combine them. Okay, so this is one example of the grouping. So now the first one we're gonna learn in the grouping, we're gonna learn the aggregation. Okay, so first one, let me call the df2. Okay, right there. So we wanna group by the features, date, and type. Okay, so df2 dot, and then group by. Okay, so I is equal to um, date and type. Okay. Then describe. So this first one, what does that mean? Group by equals date and time. So we're gonna the split and combine. The split data for each um, for each the grouping, the data frame. Split the data frame, having the same type data and date and type values. Yeah, date values So, and then we're gonna find out the statistical inferential statistics. I mean, mean and standard deviation, minimum, maximum, and then percentiles. 25, 50, 75 percentiles for each type. Okay. So see the data DF2 is grouped, split it by the date, right? Okay. So, and then for each date and type, we got the inferential statistics here. Okay. So now next one, but the reason that we got the NAN none in standard deviation because the for each date type we have only one one value, right? So for that date and type A we have one value, 11.432. So standard is actually standard deviation must be what, 0, right? But we got this the pandas gonna return none. Next one, DF4, excuse me, DF4, and then group by, and then level 0, okay, level 0. Then some. Okay, so see, no, see. Okay, so now here we've just split the data frame DF2, what we saw, and using this one, so split here, okay, having the same date values, okay, and then take some that's applied, right, and then combine again. So we got this, okay. So give me a second. I don't think we put the level. Oh yeah, so level, so we have to put it here. Sorry. Yes. Now next one. What about? Let me apply the other one, DF4. Okay. So then DF4. Now let me use other data. Okay, this DF4 doesn't have have enough rows, so let me import. Let me get data from the Python package. Okay, so I mean, yeah, Seaborn. It's SNS. Okay. So now and then planet is equal to SNS dot load and then uh, data set. Oops. Okay, the PLA NETS planets. Okay, and so I just called the planet data from the Seaborn package. Okay, so I mean, what does data look like? You see, planets that had, you see. So the data for that data frame contains the planet information. Okay, so orbit period and then mass and distance and then year. I think a year uh, found. Okay, but look at this. I mean, 0, 1, 2, 3. I mean, look at the method. Radial velocity, radial velocity. So I think the method, the value method is a categorical value. So we'll see. Now see, group by method and compute the median of or return and then period, okay, for each method. So we're gonna do planet group by and then method going to compute the median of the overturn period, that column, right? Here, and then median, sorry, it's a typo. Okay, so as you can see that in this planet data frame has I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 method. Yeah, so 10 method: astronomy, geometry, and then eclipse, timing, variations, imaging, micro lensing. So okay, for each method, the median of the orbital period is this right here. Okay, so what does that mean? For example, micro lensing. So the old planet found by the method micro lensing, their median orbital period is this 3,300. Okay, right. So now next one, yeah, we can apply the grouping in a for loop. Yeah, I didn't cover for loop, but I'll show you here in the method, in the group. Okay, the in planet, and then group by the method, and then print. So in the after column, yeah. So what does that mean? Method and the group is iterated. Okay. So but method and group is in that data frame. Okay. Okay, grouped by method. So I think we need to give me a second. So I think let's figure out. So let's figure out this planets and group by and the method. So I mean group by is it okay? So now you know you see that here right there. So group by method. Then we the head. Then this command will show us a first one. They're gonna split the data frame planets, and then split and then grouping by having the same method value. Okay, and then is the dot head. So the command is gonna show us first 5 rows for each group, for each split, or we can say. So here 0, 1, 2, 3, 4. This is the first 5 the row having this in the method group of method. Okay, maybe 5, 6, 7. I think 0 through the 28 rows, 0 to 28 index number. That rows have the same method value, radial velocity, and then 29 through the what? Let me see. Yeah. Give me a second. Mm, yeah, something. It should be like this, but yeah, let's see. I mean, it should be 29. Um, let me see. I think I think I missed this one. Still, we got the same result. Give me a second. All right, so here, yeah, I just made a mistake. So here, the group by this command, what doesn't return the data frame itself. Okay, so we have to what to put a command to implement some the apply. Okay, some or find the inference statistics, something like this. So, for example, describe. Then they're gonna return the data frame, split it, apply, and then combine like this. Okay. So for each instrument, the method, we're gonna get the uh, the inference statistic. Okay. So now then, next one. So back here. Okay. So then we're gonna print. Let's see, the Crawley bracket 0 to 30. So then this one give us the enough space for the printing. Okay. So 0 to I mean 0 to 30 points space. Okay. And then shape. Oh, shape is equal to, and then call bracket 1. Um, then format, then method group shape. So now then we're gonna get this. So the what the planet is grouped by that object. So they're gonna find the method is iterated. So for each same iterated, collecting them, and then they're gonna find the shape. Okay. So from here, for example, the radial velocity, the 553 rows have their method is radial velocity, and then 6, that means number of columns. So there are 6 features. Okay. So now next one, mm, the planet group I, and then method and year. Okay. And then describe. So here, this one, the give us what? Yeah. So the they're gonna split having the same in the grouping having the same the method value, and then they're gonna find the inference statistic for year. Okay. So the media for the astrometry, I mean all the planets bounded by astrometry, what the mean year of the planet is 2011.5. Okay. So now, here, yeah. So for this one, by the way, give me a second here. So median. Okay. Yeah, I think that's it. So now next one. Um, let me create new data frame. Okay, MP that using the random, and then random state, and 0. So what is a random state? Um, so yeah, to understand random state, yeah, we need to learn some statistical theory. But that just give you us the yeah. So I think I'll give the excuse me. Random state excuse me. So random state for using the random state, we can choose the the probability distribution. Yeah, I know. So probability, so for example, beta probability distribution, and then chi-square probability distribution, or binomial probability distribution. So the then the NP random state 0, and then what? Then they return, they gonna to choose random numbers following that probability distribution. But normally we use a 0 or 1 or 2. Okay. Yeah. So now df10, this is equal to PD data frame, and then key. Say we need to put the data key, and then A, B, C, A, and then B, okay, then C. Right, and then C, data 1, then data 1 and range 6. Range 6 gives us 0 through the 5. I mean, 0 through the 5, yes. And then data 2. Now we, you know, generate random integer 0 to 10 and 6. Just RNG random integer. That means to choose the integer randomly between 0 and 10. Okay. Actually 0 to 9. Okay. So 6. Then close curly bracket. Okay. So we see. Yep, 10. Okay. So mm, okay. Now then we're gonna next one we learn the transformation. I'll give you example using df10. Okay. The first one group by let's see, key, and compute the mean for each key in data 1 and data 2. Okay. So group by key, okay, group by key in data df10, we're gonna group by key and compute the mean for each key in data 1 and data 2. Okay. So what does that mean, compute? So we're gonna find the well, yeah, that's where we're gonna find out what mean key 1 and 2, and um we subtract. So we subtract uh the values in data 1 and in data 2. I mean values, we subtract values from what give me a second. We subtract the mean from value in data 1 and 2. Data 1 and data 2. Okay, what that means, so okay, so we see at df10 and then group by, okay, and then key, okay, so we group by key, and then now you see split, now this will split, right? Okay, and then we have to apply the some rule, right? So we just transformation, and then we apply we define simple function using the lambda x colon x minus x dot mean. Okay, then the here x we apply that one x minus x dot mean for each cell, each value. Okay, now you look at this. So we got the negative 1.5. Why we got the negative 1.5? Because the first one, oh, we yeah. So we group split this one by the key. Okay, then we're gonna get A0 and the A3, right? I mean, just considering data one, we got A0, A3. Then we're gonna compute the mean for 0 and 3, which is 1.5, right? So 0 plus 3 divided by 2 is 1.5. So then we subtract the what? 0. Subtract the mean from the 0. And subtract the mean from 3. That's what we got the negative 1. Uh, give me a second. So negative 1.5. And then for the third index 3, that row, we're going to get 1 positive 1.5. Okay. So similarly, we got all the values like that. Okay. So for example, look at this 5 and the data to value is 3, right? How do you get this? So first one grouping, the index 1 row, index 4 row. Okay. And then find out the mean data 2 key having the key value is v, which is 0 and 7, right? So find the average of 0 and 7, which is a 3.5. Okay, and then we subtract 3.5 from 7. So okay, so then you see that for I mean, so 7 minus 3.5 is what? 3.5. That's why we got this 3.5. Okay, so now next one, let's see. I wanna what if we wanna drop some rows, okay, containing NaN and the values. Okay, so that's all of the grouping. And the next one we just learn the how to drop the rows. So first one, let me use TF4 right there. So I want a TF4. Drop the rows having NaN value. Okay, we just drop Na. Okay, well, it makes sense, right? See, because all rows have contained NaN value, so we got nothing. Okay, so now yeah, so next one, yeah, I told you, but if you need um to dig out more about command, then use help. Okay, help, and then df4, and then drop na. Then you will see you can see lots of examples. Yeah, so sorry. Yeah. Okay. So now next one, mm, sometimes we need to fill the replace non-value NaN to a certain value. Mean, normally mean of the of each column. So or a predetermined value. Okay, so we use this therefore, and then fill NA. Okay, and then therefore mean. Okay, so I mean, so what's a therefore and mean? Then when you therefore mean, you calculate the mean for each what each type. Okay, so each type means that for each column. Okay, column A, column B, column C. A, B, C are column label, right? Or you can say feature. So, all right, and then see that all the non-value are replaced by mean, right? Column mean. Now, next one, I want to replace values with others. So let me do df2. Okay. So right there. So I want to div2 and then replace A. Okay, I want to replace the type value A with F. Okay. The next one, combining data. Okay, let me say data one, go to PD and data frame. Okay, and then open curly bracket. Okay, and then X1. And then ABC. X2. 11.432. 1.330. 99.906. Okay, and then data one. Let's see. All right. So now then, see data two. This is equal to PD and then data frame. And then ABD. A, B, D. Yeah, and then see X3. Okay. The 20.7 and NAN. And then 20.7. 20.7. Okay. All right. So now, and then let me define data 3 too. Data frame. Y1. ABE. The Y2. 1, 2, 3. So, and then I want to merge. So, merge. Okay. So PD, let's see, we use a PD and then merge. Okay. The data one, and data two. So look at this, data one and data two. Data one, data two have uh, the same, I mean, the column X1, I mean, they're going to have same the feature, right? X1, X1, right? But the features value, I mean, attribute is different. Here is ABC, but this is ABD, right? So we have to decide which column, I mean, the X1 in the column X1 in data one or column X1 in data two, which one do we have to use? Okay. So now we see data one, data two, and then we use how, okay, how, and then we use the left, and then on, oops, X1. It means that we use the what? The left means we use uh, the left, I mean column X1 on the left data frame. And we got this. So we got the X ABC, right? But definitely, you know, we use a column X1 in data one. Since the what? Data two, there is no value whose see, there's no row whose X1 value is C. So we got NaN right there. Let's see. So yeah, what about, yeah, same, let me PD RG and then data one and data two, and then how, and then right, okay, on X1, whatever. Then we're gonna get ABD, right? instead of ABC, so here, then we're going to get any value in column x2. Okay. I mean, so this is just a one example of PD merge. So when you type help PD merge, then you see a lot of parameters options right there. So please read it. Okay. So here also we have a lot of examples. So now next one, then PD merge and data one, data two, and a how and inner, okay, on x1. So what does that mean? So inner means that so they're gonna merge having the same x1 values. Okay, so that's why we're gonna get only two row. Okay, then guess what? There is outer, right? PD and then merge and data one and data two. How outer on x1. Outer means the combining. I mean the combine the column x1 in both data one, data two. Okay, so that's why we got A, B, C, D. So, okay. Now, let's see. Next one, join. Means that merge to data frame with changing features name of overlapping column. So data one and join data two. Okay. The left surface suffix is one. It means that we change the features name. Okay, we join, we combine, merge data one and data two, and then we change service because data one, data two has the same column label x1, right? So we're gonna change the x1 and the data one to x1, the sub dash one, and then we change column label x1 in data two into the x1 sub dash 2. Okay, now we see that here. Okay, excuse me. So now, yeah, this is also hope that please, I mean, please please look at the help of the command join. Okay, so now concatenate. Okay, let me see. So concatenate. So right here we're gonna see vertical concatenate for series from this. So S dot append S2. Okay. So what was this? S is series having the uh having four rows A B C D, and the S2 is the series whose size is one, two, three, four, five. Right, five, having the five rows. Okay. So we just combine vertically. So simply just combine the A B C D and then A C D E B. You see that? Okay. Just vertically is the stack. Okay, S2 over S. Okay, I mean S over S2. So now the next one, horizontal concatenate. Okay, series. So PD and concat open parenthesis and then S comma S2 and then axis is equal to 1. X is 1 means what? This is X is 0. Remember that? Remember that the direction of X is 0, 1, 2. X is 1 is the what? Um, the uh, the column direction, right? Okay, column 1 is to column 2, column 3. Okay, so in the key, so it means the horizontal direction. So 1, 2. Okay. Oh, let me see. What did I miss? Yeah, it should be keys. Okay. Sorry. Yeah, so we got this. Let me see. Okay, so here, give me a second. B C D A B B C D. Okay, so since the in the first column 1 is data 1. I mean S. Then column 2 is a series S2, right? But a column 1, which is series S, doesn't have data value E in index E, right? That's what we got NAN. Okay. So now, next one, and then also when you use this one, then you see that the order of rows in series S2 will be changed. You see that S2 is A C D E B, right? But here too, we're gonna A B C D, right? Okay. What if we change? Give me a second. What if we change the S and S2? S and here. Then the order of row will follow the order of the series S2. Okay, keep in mind this. So now, next one, let me see, PD and concave, and what about the data frame? Okay, data 1 and data 2. Then axis 0. So axis of 0 is what? The vertical direction. Okay, right. That's why we got this. Okay, and then next one is the. Then what about how can you the combine data 1, data 1 and data 2 horizontally? We have studied right here more moles words, right? Okay, so look at this. Now we're gonna the last one is date. So convert the data type of the column date into date. I mean, look at this df2. Remember that here when we create the df2, we just manually type the these date, right? Okay, and then the data type of this is not is a string, right? Not a number, not a date. So we want to change the data type of this column date to actual date. Okay, so df2 and then date. Okay, pd and then date range. Can use this one. Okay, 2000 January 1st. Okay, period is equal to 6. Q is equal to. So now we can do this. Oh, we see that TF2. So what does that mean? So now to the 2000. So starting from 2000 January 1st, okay, and then we're gonna this command generate the 6 date, okay, it said period 6, okay, and the frequency is a month, okay. So that's what we got. This 2000 January 31st, Okay. So and the next the date, which is after a month, gonna be February 29th, and the, you know, you see that, right? What if we this is January 1st, not January 1st, but January 31st? But still, we're gonna get same, right? Okay. What if we're gonna get January 15th? So we're gonna get same thing. Okay. Now next one. I mean, so help. By the way, help. You can see that PD and date range. Then you see the command for the frequency. Okay. So you see string or the offset default D frequency string can have multiples 5H. Okay. So I mean, see, for example, let's see, yeah, the yeah 3M MM. Okay. So or frequency none. When you the what? So when you just the type the date manually like this, then you have to set data type of this one to date time 64 and then open bracket ns and the frequency none. Can you mind this? Date 64 ns. That's the data type of date. Okay. So now and the other options frequency, if you want to see that, then just go to the time series dot offset the LIs. Okay, let's look at this now. mm, Next one is create date index. Okay, so from here we have to call this one import date. Okay, and then date is equal to then date 2012 February 1st, and then date 2012 February 2nd. Okay, and the index, PD, data frame, and date. Then we see index. So we got this, right? So now here, I mean, also index, let me see, info. Okay, then yeah, is here data type of the index, data frame index is just object. Yeah, I don't see, but it should be the data type must be like this. Data type must be date time 64 ns. Okay. So now next one, and then mm, now create a data frame using a date index. Okay. So now the index is equal to PD, then date range. First one, we're gonna create the index. Okay, PD date range. Okay, so it's the start. It's equal to January 1st, 2018. Yeah, you can write the date as like this using slash. Okay, and then period is 5. The frequency is the day. Okay, so now the index. Look at this. The index. Let me see. What's wrong? The index PD dot date range start. Periods. Yes, always confused. Okay, period. So you see the data type, date times 64 in S, right? Okay, so we created the index, and then we gonna create data frame. Uh, Data frame. Okay, then we need to create a column, right? This is A, B, C, B, and C. Okay, you see. So now, and then index, the index. Then we see the. Now you see that here. So we got the index, whose data type is what? Yeah, date times 64 ns. Okay. All right. So now next one. Oh yeah, that's it. Okay, that's all of the comment in the cheat sheet. Okay. So next time, um, mm, yeah, we'll see uh the practical examples of pandas. Okay. So maybe I'll give a hint in pandas homework. Okay, and then we're gonna take a look at it. Okay, so that you're gonna be familiar with all the commands we learned in pandas, and then you had, yeah, definitely you have to familiar with all the commands. Okay, how to deal with data to do analysis of data. Okay, so that's for today. Okay, so any questions? I'll leave your question in the discussion board in Blackboard. Okay.